Hi there. Thanks for joining us for Program Nights Week 2021. So I'm Anoop Sharma. So I'm a senior software engineer in Cognizant Softvision. So I'm here for our last 2 years, and I'm mainly a Microsoft tech stack developer, basically more concentrated on the backend activities, especially on cloud native application development. So my main role and responsibility was leading the backend activities, especially on .NET Core. So I have more experience in that area. So I'm really excited to talk to you about a topic, Azure Functions. So I'm pretty much sure that you guys already know about this. You guys already used or heard about Azure Functions before. That is for sure. So I don't want to wait. I don't want to wait you guys much time. So let's get started to the topic. So I'm really encourage you guys to ask questions if you have any. I'll try my best to answer those in the end of this session. So let's get started on the topic Azure Functions. So as I said, you guys already know, you guys already heard about these Azure Functions before, especially from the cloud native application developers. So before getting into started this Azure Functions or what is Azure Functions or what is the use of these Azure Functions and all, we can straightly go to one or important topic or one of the big topic which we are discussing right now in the tech industry is called serverless architecture. So what do you mean by serverless? The term is a little bit weird for the web application developers because without server, how we can able to host the application, how we can able to build the application, how we can able to run the application. So the serverless architecture, the term is a little bit weird. So you should have some basic idea about serverless architecture before getting into the topic Azure Functions, because Azure Functions is somewhat a serverless architecture. So as you can see here, the serverless is a new buzzword that has been gaining a lot of attention in the tech industry, especially because of the introduction of Lambda by AWS, which is a serverless architecture based technology. We can call this a framework, which is introduced by Amazon Web Services in 2014, where the serverless era comes. Okay, like serverless, what is serverless? Serverless. Right now in web application, what we have to do is we are building web application, especially in .NET. If you have in .NET, we are building web application. We are building REST APIs using web APIs in .NET Core and all. And we are hosting this application to a server. There's a server is must required. There's a server is required when you are hosting an application. We are running an application. So what is this serverless? Serverless means there is not something like that. There is no server. The server is there, but from developer perspective, we don't want to worry about server. We don't want to purchase server. We don't want to maintain our infra. We don't want to look into the RAM. We don't want to look into the memory. We don't want to look into the performance and all. These vendors like Amazon, like Azure, Google Cloud, these vendors will handle these kind of things on behalf of us. So that is called serverless. The server is anyway there, but we don't want to, as a developer, don't worry about this serverless. We don't want to maintain all these things. These vendors can able to handle all these things on behalf of us. We have to concentrate only on the business logic, on the client requirements, basically. No need to worry about other infra on behalf of us, because these vendors can handle all those things for us. So like I said, this serverless architecture, we can, when it comes to serverless architecture, the term, like we have, when it comes to the cloud, we have heard about this PaaS, IaaS, and SaaS services. These kind of terms we are already very familiar with. When it comes to serverless, we can hear that functions as a service. Functions as a service means the little bit of piece of code, you can say as a function, can able to run in a remote server. And that function can able to run on a remote server. We don't want to worry about how the function is running behind the scene, how the vendor is maintaining that function behind the scenes. We just want to write the code, write the business logic. We can ask the vendor to maintain that function. Just when the requirement comes, this function able to run behind the scene on the background and produce the necessary output. This is basically the function as a server model that allows cloud platform to execute without need to fully provision infrastructure. The infrastructure is provisioned based on the provider, what is the vendor who is providing that infra. And in traditional web application or traditional server-based application, what is happening? We are hosting an application into a server. This server is hanging. The server is up and run always when we are hosting an application. Even sometimes, because some of the web application is not required to be run anytime. Every time it's not required to be supposed to be run. It sometimes is not required. There are some kind of application which doesn't have much of the latency, like much of the requirements, and those kind of application, we should up this server always, even if you don't want this application every time up and running. So what is the disadvantage of using that kind of model? We have to pay, we have to maintain the server always, we have to maintain the cost, we have to pay the cost for the server. Yeah, like I said, these vendors, AWS and Azure kind of vendors, can able to handle this serverless or infra on behalf of us. You don't want to worry about this function. You don't have to worry about maintaining how we are as a developer. We don't have to worry all of these things. These things can be handled by the vendors like Azure, AWS, and Google. So, like I said, function as a service, this we can strictly concentrate on the business logic, what we have to implement. So that is called serverless architecture. The server was there, but as a developer, we don't want to worry about this architecture, infrastructure, and all. This can be handled by the vendors. And the next, when it comes to the next topic, Azure Functions. Azure Functions, as I said, this Azure Function is based on this serverless architecture. So what is meant by Azure Functions? Azure Function is just a simply an implementation of this serverless based architecture. Like I said, Amazon AWS has introduced Amazon Lambda in 2014 as a implementation of serverless or a function as a service. You can say function as a service, as introduced by AWS, and later on other vendors can able to follow. They have introduced their own kind of implementation of serverless as architecture or a function as service. That is, the Azure has implemented this implementation as Azure Functions. So, like I said, Azure Function is a little bit of piece of code where we are writing our business logic, our implementation as a piece of code. This piece of code can be triggered. Okay, this is a function. Like in normal web APIs, how you can able to trigger? We are calling this APIs an HTTP trigger. When you are triggering an API, or when you are calling an HTTP trigger or an REST API, this API will process the data and get back the response. So there is a triggering point is there. So when it comes to the Azure Functions, there are a lot of triggers available. Like you can see, this function is execution based on an event. When an event occurs, this function will start processing or executing the business logic what we have written inside there. You can see from the image, the function is a code, and there is a triggering, this code is triggering, and there is a binding of data. What are the data we are passing, or when we are triggering the function, we have to pass some data to the function, right? So the binding is data binding, the combination of a function code or what we are the business logic and the triggering and the data what we are giving as an input, that is called Azure Functions. So it's a little bit piece of code where we are writing our business logic, and there should be an event which is going to trigger this Azure Function execution, and the data which is going to pass to that function. The combination of all these is called Azure Functions. So Azure Function is a serverless computing service that enables to run user an event-triggered code. Event-triggered. The triggering is based on event without having to provision manage infrastructure. We don't want to worry about the infra. We can strictly write a function. We can define the event, how this function should work, and the binding of the data. We have to concentrate only on that. Being a triggered service, it runs a script or piece of code in response to a variety of events. There is a different kind of events we can able to execute an Azure function. So when it comes to this, then we can go to the next topic, how this Azure function works. Like I said, this Azure function is working based on a set of events. there are different kind of events available. Like it can work based on an HTTP event, like normal web APIs. When we are calling an HTTP method, it can able to execute the function, or we can write an Azure function based on a timer. When the timer execute or the scheduled time reaches, this function can able to execute, and we can when you are like good idea about Azure Infra, Azure services. You would have heard about Azure Blob and Azure Queues. So when it comes to a new message into a queue, we can able to bind this Azure function to the queue or subscribe to the queue. Then when it comes to a message, this Azure function will start execute. So there are different kind of events is available on we can able to integrate with the Azure functions. So this event plus the code, the output. The function is executing based on this event, and when the event reaches, this code will start, or the piece of code will start execute on the Azure portal, and the output will get generated. So maybe the output will be if an HTTP API, the response will get sent back to the client, and if any if it's a timer trigger, we are sending a notification. That's those kind of examples. This function trigger will execute based on event and process the response, and like whatever the business logic we have written inside the function, that will get executed. This is how this Azure function works, like in a high level. And how do you call Azure function? Like I said, how do you call Azure function? Azure function can be called when triggered by the events from other services. Like it's an event-driven application platform based on event. So it have the capability to implement code-triggered events occur in any third-party or on-premise system. So these are the set of, you can see here, triggers, which is available on Azure services, Azure function on behalf of. So the details you can see here, you can see HTTP trigger. Like I said, if you want to write an Azure function, it's a piece of code, and you can able to call or execute this Azure function using HTTP trigger. If you define an Azure function using HTTP trigger, this function will get called, executed when we are calling that Azure function using HTTP methods, like any REST client. Example Postman, we can able to execute this function like the very same way we are executing an API, REST API. And the next one you can see here, it's a timer trigger. Like I said, if you want to create a scheduler, sometimes, okay, for example, if you have to send a notification to a couple of people on a regular basis, daily, every day, 9:30, we have to send a notification to or alert to every employees or something. So if those kind of situation, we are creating a scheduler, we can able to create this scheduler as a simple Azure function, and we can able to trigger using timer. We can set the timer trigger for Azure functions. So those functions will be executing once the time reaches or the scheduled interval. And the next one is blob trigger. As you know, guys, you guys know that when you are familiar with Azure, this blob is pretty much similar with what we have in AWS called S3 bucket. We are storing the static files. So blob is pretty much similar to the AWS S3 bucket. The blob storage, we are storing the files. So we can able to subscribe or bind our Azure function to the blob storage. So whenever a new file comes to the blob storage, we can able to execute, so we can able to process the file based on that, inside our Azure function. For example, if you want to, we can take an example if you want to resize image. When an image comes to the blob storage, we can able to subscribe, or we can able to bind our Azure function, like image processor Azure function, into the blob storage, into the blob container. So whenever a new image comes to the blob storage, we will get the image or file into our blob trigger function. We can able to process the data, and whatever things we can store back to the blob storage, we can store back to any other source or something. So that is blob trigger. And the queue trigger, because I'm sure that everyone has aware of the queue. What is queue? Queue. So when it comes to the event-based architecture, this queue is performing a good role. So when it comes to the queue trigger, we can able to create a function, Azure function. We can able to trigger this Azure function whenever a message comes to the queue. So when a message comes to the queue, this function will automatically trigger based on the queue, and we will get the message. Whatever the message comes to the queue, we will get the message, and we can process the message based on the data which we are receiving. And when it comes to the next Cosmos DB trigger, so like Cosmos DB is a kind of NoSQL database in Azure services. So we can able to process document, Cosmos DB document, when they're added or uploaded to the collection in NoSQL database. So when a new document or a collection of data comes to the Cosmos DB database, this DB, whatever the function we are binding to the Cosmos DB trigger, it will start executing, and we can able to process the data, process the document as well. So this is Cosmos DB trigger. And there's another trigger called event grid trigger. Event grid responds to an event delivery Azure subscription, Azure event grid. So whenever an event happens, this Azure function, whatever the binding Azure function, will start executing. And the service bus queue trigger, service bus like when it comes to service-oriented architecture. So in Azure, we can use service bus. So we can able to create function, we can able to bind function to service bus queue as well. So whenever a new message comes to the topic or in a queue, this function will automatically get triggered, and based on the message in the queue, we can start our business logic, or we can start our application function. So service bus topic trigger. So similar to service bus queue trigger, instead of queue, we are subscribing to a topic. So when a message comes to the topic, this Azure function will start executing, and the data will get processed, or the function will start executing our business logic. So this is the basic triggers which available, which supports Azure Functions. There are a lot many. I have given just a basic 10 important triggers which is mostly used by nowadays. So this is the basic triggers which can able to trigger and even Azure Functions. Then the next thing is how to make an Azure function. So we have we have gone through what is Azure Functions and how can able to execute the Azure function. The next thing is how do I make an Azure function. So Azure function can be made using the basic four. You can see here the basic 4 methods or available option when you are creating an Azure function. You can able to create Azure function using Visual Studio. You can able to create Azure function using Visual Studio Code. These are the 2 IDEs available from Microsoft. And you can able to create Azure function in the Azure portal itself. You can log into Azure portal. You can simply create an Azure functions in the portal itself. And also Azure provides CLI commands. So you can able to create Azure functions using the CLI also. So Azure Functions basically built in 2 ways, either using Azure Portal or Visual Studio. So before getting to creation of Azure Functions, I can explain the language, or which language we can able to use. We can use to create an Azure Functions. The basic support is C#, JavaScript, F#, Java, PowerShell, Python, and TypeScript. These are the languages we can able to create Azure Function. There is no type coupling. We have to create Azure function only using C# from since this is from Microsoft. We can able to use other languages like Python and TypeScript on C#, JavaScript, and all for creating an Azure function. So creating an Azure function in Azure portal, it's easy. I'm not going to explain how we are going to create in Azure portal because it will take too much time. We can't able to finish in 1 hour. So when creating an Azure function, you can able to create, when you are familiar with Azure portal, you can able to search an Azure source, you can able to create a resource, and you can see some function app. There is a type of Azure resource called function app. You can select a function app and create that function app, and you can provide necessary details and create it. So it's very simple for creating an Azure function in Azure portal. When it comes to the Visual Studio, in Visual Studio, if you are familiar with using the latest Visual Studio 2019 itself, you will get a template called Azure Function, like a project template. You can able to create this Azure Function using that project template. When you are clicking on a new file and taking a new project, you will get a new template Azure Functions, and you can able to create that Azure Function using that new template. And so while creating that new template, you have to provide the binding which you would like to have. Like we expect, you can have a HTTP trigger, you can have timer trigger, a lot of other triggers also available. So when you are creating a new function using Visual Studio, you have to mention what trigger you have supposed to go for that function. So this is, you can see here, this is when it comes to the Azure function in Visual Studio, the first image. When it comes to, when you click on new project, you will see Azure function as a project template, and you have to select, you can see here the different kind of triggers like I have explained just before: blob trigger, Cosmos, DB trigger, event hub trigger, the queue trigger, IoT trigger, service bus, service guest queue topic. So you can select whatever the trigger which you would like to have, click on the trigger and start creating that. And what are the like function name and the access storage emulator. If you have like, you can select storage emulator if you want to run this application locally. So these are the basic things. And this is when it comes to the Azure portal. You can see the second image. You can select Azure function in the portal, create a new resource, and you can choose the function app, and you can also able to like decide the trigger which you are going with. So you can able to create Azure function using portal as well. So this is a sample function app which you can see here, which is an HTTP trigger Azure function. So this is written in C# in .NET Core. So this is the structure of an Azure function when you are creating an Azure function in Visual Studio. You can see here, you can give whatever the name you want, and you have to provide the function name here. Like this is a sample function which is sending an email. It's a sample application which is triggered by an HTTP event, and it is sending an email to the users. So you have to provide the function name here, and you have to mention the trigger. This is an HTTP trigger function. So that's where the first parameter or the attribute is HTTP trigger. And whatever the business logic you have to supposed to take here, you can able to process the logic here. And from the HTTP request method, this is an object where you can able to access the data. You can get the data, whatever the data which is sent from the client, you can able to access. So this is a sample Azure function. It's a function name, and you have to provide the function name, and you have to provide the trigger which supposed to trigger this function and process the data. And since this is an HTTP trigger function and the response type is iAction results, I'm pretty much sure that as a .NET developers, you are very familiar with iAction results, which is similar to what we have in Web APIs or ASP.NET Core MVC or ASP.NET Core APIs. So iAction result is similar to that return type, and we can able to return iActions and whatever this, like here you can see it's an OK result. So when this function execute, process the data and send the HTTP response, 200 response back to the client. So this is a basic example. I will show you the live example later on this topic. And the next one is another important topic is scaling and hosting. So when it comes to the traditional server-based architecture or server-based application, what will happen? For example, if you have a situation, the number of users is increased or huge number of users started using this application, what we have is we have tried to scale this application either vertically or horizontally. So that responsibility in our hands. We have to decide, okay, how many users we can have. Okay, again, like there's a new 100 users will comes. So we have to decide, okay, we can able to go horizontally, and we can able to introduce new more servers. We can able to scale up. So this is handled by us, and we are able to like evaluate or analyze all these things, and we have decided to go with how many servers we want to like increase the performance. So when it comes to the serverless architecture, when it comes to the Azure function and all, this Azure function built to be scalable by default. By default, in the sense, since we are not going to maintain this infrastructure on top, this vendor is maintaining infra on behalf of us. So whenever there is a huge number of pressure on the like triggers, this vendors can, or this infra can automatically scale up based on the requirement. We don't want to worry about, because this is pay as you go model. I'm sure you guys have heard about pay. So we are paying only for the execution time. So when a request comes, this function will be executing, and it will process the data and return the data, or whatever the process completes, it will go down. So we are paying only how much time the function executed and the resources which is used for the execution. So and then a huge number of like requirements or huge number of pressure on the trigger, this function will automatically scale. The vendor is automatically doing on behalf of us. This function will scale based on the requirement, and it will process all the data in parallel, and it will go back to or deprovision the instances. So we don't want to worry about the backend pressure on our functions. It will handle automatically. Okay, you can see here the normal VMs are because we are always CPU. We are paying for the service, paying for the and it is using the RAM efficiently. So, and it is difficult to decide on how much number of resources all time we need to. There is a peak time, and some days there is not that much peak time. So it is difficult for us to we have scale up. So if we are using Azure Function so it will handle these things very efficiently by the vendors. So the runtime is always monitors the various way function can be invoked, and it will provision the additional instance of function automatically as needed. So once the load has lowered, so when the peak time is covered and the function is as load has lowered, the runtime then deprovision the additional instance which is already provisioned. So this means never need to over provision or fear not meeting the requirements, because it will happen automatically. We don't want to worry. So in the right side, you can be able to see this when it comes to the hosting and plan. There's a two type of plans which is available in Azure. One is consumption plan and one is app service plan. The consumption plan is nothing. This is the default plan which is available in Azure. So which is pay as you go. Like I said, the use model, and the scalability is automatically handled by the Azure itself. When it comes to the consumption plan, we don't want to worry about infra, we don't want to worry about everything. It will handle automatically by Azure Function and on the Azure infra. So when it comes to the next plan, this is app service plan. So here we are provisioning a VM which is very specific for Azure Function. So if we have a VM already available in Azure portal, we can able to decide host the function in the same app service plan. So this function will execute on top of the app service which is already available. So in this case, the number of cores that goes this Azure function executing on the VM model. So whatever the RAM and whatever the core which is there in the VM which we already have, so this choosing the right configuration should be thoughtful, as the price directly affect. The price will affect directly on the choosing when it comes to the app server. We have seen how to create an Azure function using this template, and when it comes to publishing or hosting this Azure function into Azure or infra, that is also very easy. When it comes to which are developing an Azure function using Visual Studio, you can simply just right click on the project and you can able to publish that project or function into Azure portal. That is very simple. Like normally in a web application, we are publishing in MVC or AP application using the similar way. We can able to right click on the project, click on the publish and give the necessary details. For example, if you have hosting an API into an IES, you can able to host that application directly from the Visual Studio to the IES profile, right? The similar way, we can able to create profile for Azure in our Azure account in Visual Studio, and you can able to create publishing that Azure function directly from there. And this is how this Azure function can be published in Visual Studio. I will go to this code when later on this topic. Like I said, we can able to publish Azure function from Visual Studio. When you right click on the project, you will see this one. Normally what we are publishing a web application on an API MVC application using Visual Studio. So right click on the publish and you will see you have to select the target as an Azure and you can provide the subscription details. You are going to publish this Azure function into your Azure portal. So you have to provide the subscription details here. You have to create the profile. So when it comes to the finish and publish, this Azure function will automatically get deployed into Azure portal. So this is how we can able to publish Azure function. So the next thing is when to use Azure function, or how which situation you have to select Azure functions instead of this normal web applications. So there are a lot of different ways. I just given a basic three or situations where you can able to choose Azure functions. The first thing is schedule task. As I have explained on the beginning, you can able to create Azure functions for some scheduled tasks. For example, if you have to send reminders every day morning to the users, those kind of scheduled tasks, or you can able to perform some syncing between two data sources. So those kind of situations you can able to create Azure functions as a scheduled task using the timer trigger, which we have already explained before. And like I said, as reminders and notifications, in that situation, you can able to Azure functions. So the one thing we have to keep in mind every time, we don't have to keep this Azure function running long time. Keep simple as possible. It should be very short execution time. For small piece of code, short execution time, we have to keep Azure function. So that's one of the important things we have to keep in mind. So it should be short-lived. And the next one is for lightweight APIs, we can able to create Azure functions using HTTP trigger. Like I said, explain on the initial topics. So we can able to create web APIs using Azure functions using HTTP trigger for the lightweight APIs. So these are the basic situations where we are able to choose Azure functions as our development platform. And when it comes to the another topic, one of the important topic in Azure functions called durable functions. So we have explained Azure functions is a small piece of code which is able to execute on Azure portal itself. We don't have to worry about infra and all. So it is a small piece of code which is executing in short term, in short time, it will execute quickly. So there are some, when it comes to the microservice architecture world, we very know that there are different kind of services available. So, and what will happen if you go with we can mix microservice architecture and Azure function? We can able to create this small piece of microservices in Azure functions. Or what will happen if you want to like coordinate a set of functions or set of APIs in a single execution context? When it comes to this. Like in microservice architecture, there are bounded contexts where we can able to execute different kind of services on a single execution context, or it should be executed in a single context. So in that kind of scenario, what will happen if you want to execute different set of Azure functions, and it should manage the context in a sequencing managing. So when it comes to that area, this Azure has introduced, or Azure has given a solution called durable function. Durable function is nothing but it is an orchestrator which can able to orchestrate different set of small piece of functions, and it can able to coordinate all these functions and the execution. So this Azure durable function is an orchestrator which can able to coordinate the activities of different activity functions and produce a response, or we can able to manage the context. So that's why the introduction of Azure durable function. You will see the manageable sequencing and error handling in Azure functions. Normal Azure functions is difficult. So in that area, there should be someone should coordinate the activities of different functions. So that's the area this durable function has introduced. So a durable function is an easy way to write stateful workflows in a new function type of durable function. This is an orchestration which provides more control for building workflows. Like I said, we can able to create workflows using these durable functions, which can able to coordinate this different execution of different functions. So this is how this normally durable functions is start executing. They should be started because someone should trigger this durable client, right? That is called durable orchestration client. This client or this function will start triggering this orchestrator, and this is also a type of function called orchestration function. This orchestrator function can able to start different activity functions in parallel, and it can able to execute this function in either in sequential order or in parallel. They can able to manage, or they can able to coordinate this different activity function or different piece of small functions and process the business logic. So this is how this orchestrator or the Azure durable function working. And this is an example of durable function. When we are writing an Azure function like this durable orchestration context, this is the context where we are this object where we are using to start our activity functions. So using this, you can see here this orchestration function starts 3 activity functions inside this execution. Like first it called activity function called F1, then activity function called H2 and pass the parameter as X. And the next one is called activity function F3. These are the name of activity functions. So this activity function is a type of function, and orchestration function is also a type of function. And when it comes to the final topic of benefits of Azure function, so I have given like some of the basic benefits what we are getting from Azure functions. The first one is robust developer experience. As you know that this Azure function can be implemented even in variety of languages. So that is one of the important benefit for a developer. So they can able to choose Azure function development using their own languages. Like you can able to choose C#, they can able to use Python, TypeScript, JavaScript, or any other script languages. This Azure function can able to write. So that is one of the important advantage. And like we have seen, lot of triggering options is available. They can able to create Azure functions using HTTP trigger, like a very small piece of web API, or they can able to create Azure function for different triggers like queue. They can able to blob trigger. So those kind of different kind of wide range of triggers available. And there's innovative way of accessing and processing data. So developers can simply interact with other data sources and service function without worrying about the data flows to and from a function. So that is also an important advantage. And the next is the serverless execution model. That is also a very important benefit of using Azure function. It's a serverless execution model. We don't want to worry about infra, and it's a pay-as-you-go model. We don't want to pay much cost. Whatever the usage, we have to pay on the resource, only resource what we are consuming. And the next is it's an open source, and then that can able to run anywhere. So we can this function we can write function since an open source runtime, we can able to run this function anywhere. So that is also an advantage of using Azure function. So these are the benefit of Azure function. And so I would like to share one example using different in Visual Studio. Like I have created a couple of Azure functions using, and I have created some samples like the triggers which we have explained right now. And this will be you can see the icon here. When you comes to the Azure function, you can able to click File, New Project. You can able to choose Azure Functions template. This is a project template. This is available in Visual Studio. You can able to choose this Azure function, and you can able to create function. You can able to create a function name and whatever the normal the way we have creating a web application. And you click on create. When it comes to click on create, they will ask for the trigger. Like I said, you can able to choose which trigger which you would like to have for your Azure function. It might be an HTTP trigger, it's a timer trigger, queue trigger, whatever trigger you would like to have. You can able to choose that trigger and create it. So it will create an Azure function for you. So I'm not going to create right now because I already created. So I don't want to create. So when it comes to this. When it comes to this Azure function topic, as I said, we can able to create Azure function using this Visual Studio itself, and a lot of Azure function is already available, which is already written in some HTTP. So you can see here, this is an HTTP trigger-based Azure function. You can see the function name here. This is a run. The name of the function is run, and I have given the name as HTTP. We can able to trigger, like this is a URL. which is going to be generated when calling this Azure function. So you can able to create the function name, and we have mentioned it, this is an HTTP triggered function, and what are the method HTTP works that supports. This method supports get and post, and this is a request method. We are getting the data from the client, and we are just whatever the business logic we have how to do inside this function, and we are just simply returning the result back to the client. So this is an HTTP based trigger function, which is already written using the Visual Studio template. And this is another sample for blob trigger. So this is the function structure is pretty much similar to all the function, except you can see the trigger. So when it comes to HTTP trigger, it has mentioned HTTP trigger here. When it comes to the blob trigger, this is a blob trigger. And in the blob trigger, what the things we have to do is we have to provide the connection string to the blob storage. Then only this function can able to subscribe to that blob. When a new file comes to the blob, the file need to be passed to this function, right? So that's why you have to provide the whatever the connection string we have to provide. And the name of the container we have to provide the name of the container where the file is residing. So when a file comes to this container, it will automatically trigger this function and pass the file as a bytes. You can be able to see this bytes file. You will receive the file stream here, and you can able to process the data or whatever the things which you would like to have. And an example queue trigger. In the queue trigger, the structure is same. You have to provide the function name, and you have to mention the queue trigger here and the queue name which you have supposed to have. So this queue trigger function is subscribing to this queue. So when a new message comes to this trigger, this will start execution. So this function will get the message in the myQueue item as a string message, and we can able to process the message whatever the business logic we have. And this is a sample timer trigger where we are creating the function, and we are providing the timer trigger. So this is a cron expression. Cron expression, I think you guys are already familiar with cron expressions. So here what they are doing is they are defining the time or the scheduled time or when this function should start execute. So this is this function you can see here. This is a second and minute, hours, month, and day of week. So this is a structure called cron expression. And this function, what I have written here is this function will execute every 1 minute of every hour, every day, and every month. So every minute this function will start execution. So you can able to provide whatever things which you have, which you require, or based on the schedule which you would like to have. So this function will execute when the scheduled time reaches, and we can able to write the business logic whatever we have inside this function. And next is this sample orchestration function. As I said, as you have seen in the previous slide, there is some triggering is required to start the orchestration, right? There is an orchestration client is required. So I have written a HTTP trigger function here. This is an HTTP trigger function, which is nothing but which will start which will execute or start the orchestration. So this is iDurable orchestration client, which is a client which is automatically injected by the framework, and using the start, you can able to start new orchestration. This is a sample orchestration. You can see this is a Azure function, and you have defined this is an orchestration trigger. It is triggering by an orchestration client only. This is an HTTP trigger function. So when you call this API, this function will start this orchestration, and the execution will comes here. Inside this orchestration trigger, orchestration context, this orchestration trigger can able to call different activity functions. They can able to coordinate. So you can see here there's a function. I have written activity function. This is a sample function. Say hello, and you can see here this is an activity trigger. This function can be triggered by using an orchestration function only, using this orchestration context, and it will be able to call this activity async. So the function name, say hello, and then this is an activity trigger. So this orchestration client called these activity functions using this context called activity async. So here you can see here this activity function, this sample activity function is called thrice inside this orchestration. You can have any number of activity functions inside an orchestration. They can able to manage the sequence, they can able to maintain the state of this orchestration. So this is how this orchestration function works. And as I said, as we are familiar with the web APIs and ASP.NET Core project, we can have a startup class where we are writing the configuration, we are writing the dependency injection things in the startup class. Similar way, in Visual Studio for Azure Function project, we can have the startup class in place like this, and we can able to write our dependency. We can write able to service dependencies inside this startup class. The only thing you have to make sure is when you are creating a startup class, we have to override from this function startup class. This is a function startup class which is provided by default by the framework itself. It's a Microsoft extension which is already available. We have inherit the startup class from function startup class, and we have to override this configure method. This is very similar to what we have in Web API or ASP.NET Core projects. We have a configure method, we have to override this, and we can able to define or we can able to register the dependencies what we have for our application. Like we can see here, services.addSingleton, which is similar what we have already in APIs. We can able to define or you can able to register the dependencies inside this configure method, and you can able to inject the same. I have like in the sample in HTTP sample trigger. In the constructor, I have injected the sample service provide iService collection as a dependency. So the framework will automatically handle the dependency injection. The similar way in the ASP.NET Core, we will get the injected dependency inside class, inside the function, and we can able to do whatever the business logic we have or whatever the things. For example, if you have an external service, we have to process the data from here. We can able to inject the dependencies inside this constructor, and we can able to use this from here. So this is how this Azure function will work on Visual Studio. You can able to run when I run this project. You can able to see. Another important thing is we can able to debug this Azure function locally. That is one of the important benefit of Azure function. You can able to debug at the normal application. You can see when I run this application, these are the list of. You can able to see there are 6 Azure functions already available in single Azure project app. One is sample HTTP. It's an HTTP trigger which I have created. And another one is orchestration client, which is also an HTTP trigger, which is going to trigger this orchestration function. And another one is blob trigger. And there's an orchestration trigger, which will coordinate the activity functions. And there's an activity trigger, which will execute the say hello. And a queue trigger, which will execute when a message comes to the queue. And there's a timer trigger, which is like a scheduler, which will execute every 1 minute. So this is the basic how we can able to run an Azure function locally. So that is how the Azure function will work on Visual Studio, and how we can able to create Azure function in .NET Core. So I have written this Azure function in .NET Core 3.1, the latest framework, which is provided by Microsoft. So this is what I try to explain is the basic concept of Azure function. I'm pretty much sure that it's a vast topic. We can't able to explain all things in a short span time. So what I would like to have is a basic understanding on the Azure function to share some idea. So this is how the Azure function, the basic workflow of Azure functions.